Okay, I'm going to talk about how to handle some of the work for part 2 of Lab 3. So, the approach in looking at this and figuring out what to do really involves taking a look over the whole set of directions. And we can see that we first want to understand what the problem is. So when we scan things around, in addition to the computer work, we really have to understand what the objective is here. And we are given a set of measurements, temperatures and pressure, that's T and P, and there's evidently two things that we need to do. One is that we want to plot temperature versus pressure, and we're supposed to make the plot blue. And then what we want to do is some sort of curve fitting, and we want to fit a line to the data, and then answer some questions which are in these parts. Okay, so let's look at the first part, which is the plotting. Now let's start off by just figuring out what to do. We want to have a new Maple worksheet. And if we go back and look at the directions, we see that we have a bunch of numbers, and we're supposed to enter them as two lists. So evidently we want to have one list that's the pressure data. So it would be this. So let's see whether we can just copy this information from this worksheet into our fresh, clean worksheet. So we'll do that. And let's see what we get. All right, so evidently when we did the copy, we got this error message, unable to match delimiters. And often when you're typing things in or you're trying to copy it from another source, you can make these kind of mistakes. It's really a typographical error. For those of you who've done the reading, you know that the way Maple lists are, now let's see whether I can change the zoom factor here so you can see things a little bit bigger. You can see that lists are supposed to start with a bracket and end with a bracket, but there's no ending bracket here. And that's really the source of these delimiter complaints, is that you don't have the right number of matching parentheses, whether they're square brackets or curly braces or whatever. They're supposed to come in matching pairs. So we can fix that by just typing the closing parentheses, editing the expression, and hitting enter again. Okay, so we managed to do that. Now let's enter in something called T data, and we're going to enter these numbers in. So this is where you're sort of on your own. And what was the last number? 100.3. So even if we're not copying it, it isn't that difficult just to type in a list of numbers. All right. So far so good. We managed to get the two numbers in. Now according to the step, we're supposed to, after we get the numbers in, we're supposed to produce a point plot. So the question is, how do we do a point plot? It says, well, in Chapter 6 of the course readings, there's some discussion of that. So let's see whether we can find Chapter 6 of the course readings. I think I have it someplace. Under Adobe, yes, I have the chapter readings here. So here's Chapter 6, and you can see that right around page, what is it, 76, there's this discussion of plotting points. So here we see that somebody's entered in two lists, and then they get a point plot by doing plot of the two lists style equals point. So let's see whether we can get that to happen here. We'll just do something similar. We'll say plot, and then T data, P data, and then style equals point. Let's see what we get. Okay, and sure enough, we do get a nice point plot. Now, actually, this isn't really sufficient for engineering purposes. We would like to add in a few options so that we can get, for example, axes labels. So I happen to know from my experience in using plot in the past that this is the way you do it. You know, if this is supposed to be temperature in Celsius, and the vertical axis is supposed to be pressure in, what was it? What was the units? Kilopascals. then we can do something like that. Okay. And if we don't like these little dots, we can make the symbol size bigger. Let's make it 30. Well, 20. Okay, and you can see that we have bigger data points. Now, how did I figure out that I needed to use symbol size and labels? Well, I've done some reading in the chapter readings. There's also, if you go to Maple under Help, you can go to Maple Help, and you can type in plot. After a little bit of time, you see that there's this. And if you scroll through the help page, it shows you some of these things, like here's another example of point plotting. The examples are often useful. Down below, there's actually a little section that says plot options. So let's scroll down, and you can see that plot options is right here. Okay, so if we click on this link, then we'll see a whole lot of options. You can see that the labels option is here, and the symbol size option is here. So the default is 10, so when I was asking for a symbol size of 20, it was really something that was twice as big. Okay, so suppose we wanted to annotate this a little bit after doing this part of the work. So what would we do? Well, first of all, I would probably go into text mode and create a little space here. And then I could sort of create a header, like cs121, lab 3, section 61, by C3PO and R2B2. Right. And then you could have a little explanation saying this is a script to plot some data of pressure versus temperature. And if we wanted to, actually in this little brief script, the parameters are the data, and the actions after that are not parameters. So we could even do something like, we could do something simple like begin parameters here, and then down here, we can go into text mode, of course, and then say end parameters here. And if we make this boldify, we have a little script that will plot temperature versus data. Let's save that as temp versus data. And where do we want to put this? Let's put it on the desktop. Okay. So now that we have our script, we can actually contemplate giving it a different collection of data. Like if somebody gives us different numbers, like 20, 40, 60, 81, and a different set of temperatures, 190, something like this. I'm just changing these numbers arbitrarily, but we can just re-execute the script now, and we get another plot with the different data. So this is the advantage of scripting, is that we can do a whole lot of temperature plots versus pressure plots if we have a different collection of data.